All right, we're here today with our Millermatic 211 welders. This is the welder that we use all the way across our shop for our basic structural repair, structural we'll call it, and our iCar testing additional to that. So uniform across the board. The only thing that these can change about is which power outlet you are running with them, which we'll talk about here coming up. First thing we're going to look at whenever we have these welders is going to be our gas gauges that are here. On top of the bottle, you're going to notice a knob. So you will very clearly see it written close and it pointing an arrow this way. And it's going to say open and it points the arrow the other way. So always make sure and close this once you're done at the end of the day. As you start at the beginning of the day, open it up all the way. So I never stand in front of these, and the risk, these used to be glass that were inside of here too, and there was a risk of possibly busting. Even with plastic today, it's still ill-advised to stand in front of them. So you'll see me stand to the side as I slowly crack open that valve. Once it's open, that gas is reading there on the gauge. I open it all the way up until it soft stops right there. So I'm not trying to force anything past. The two gauges that we're going to have, we have this top gauge here to the right-hand side. This is going to dictate how full the bottle is. The gauge to the left-hand side is going to be how much gas I am actually flowing, to be specific, in cubic feet per hour on this particular gauge here. If we look back here, you're going to see basically two of them, to where one is written in red, one is in black. The black writing to the outside perimeter is the only thing that matters to us. Where will we range at? From 25 to 35 CFH there, specifically with it. When do I dictate, how do I dictate how much gas to flow? It's always been my opinion that I can't flow too high a gas as long as I'm within my range. It's there. My average is 30 is what I like to run at with it. Could I get by with 25? I'm sure I could in closed door settings like this. The garage doors are closed. There's no fans running or anything like that. If the garage doors are open and there's a slight breeze coming through the shop, I highly encourage 35. I need that gas flow to create that inert environment for my weld. If the wind is blowing more than my gas is flowing, it's essentially going to blow that gas away and I end up with porosity that's left behind through there. So on average, though, I would say 30 is pretty good. These next couple weeks, we're going to see temperature drop pretty fast. That's through here. So if we have doors open and you're on a corner booth, I would encourage you to run 35. But on average, I would say 30 would be a good spot for that to be at. So how do I regulate how much flow I use? This knob right here. This is not used to shut the gas bottle flow off. That is what this knob is for. This is to regulate how my gas is actually flowing, how much is flowing. So if I turn it to the right-hand side, I'm going to see it increase. But if I turn it to the left-hand side, I see nothing happen until I pull that trigger. Oh, got to turn it on. The power outlet's in a weird place, which is on the back right-hand side of this welder right through here. So now that it's on, I pull that trigger and we see it go down further through there. So now we're at 25. I can tilt it back up again. We'll run him up to 35 and he'll stay there at that point. Okay, so then it's going to come into, let's start in the guts of it all with this, I think. So I'm going to sit my torch and stuff down so I can open up this. Whenever I pick up this lid, which is on the left-hand side as you're looking in at it, you're going to see a series of things that are here. Everything in here is going to be important, and we need to figure out what all we have to be able to properly set up our welder that's there. So on our wire spool that's right here, it will always be written and viewing from the outside. So this one is ER70S-6, which is our standard for welding in auto collision, period. So that's what all of these welders will be running, is ER70S-6. Ours will be ran in the 0.023 wire size, wire diameter, total diameter that's there. We can see that range from 0.023 to 0.025 and still be within a tolerance. So if you see 0.024, don't be alarmed. It's the same settings that's right through there. With that, this right here creates pressure on the wire. So it's not really creating pressure right here. It's locking here. Here we have a roller. So whenever I pull that trigger, this roller is what's actually activated and pushes that wire through to the actual torch at the end of the puddle through there. So this is rarely ever adjusted. It will always stay at 3 for us. Just for a basic knowledge, if you were to ever change size to say a 0.30 wire that's there, this knob here does need to be changed accordingly. It's just on a spring fed. You push in, twist over to where it lines up and says 0.30, or additionally 0.035 we can have with that as well. But ours is on 0.024 specifically. Okay. It's going to walk us through everything we need to find our setting at, period, with this. There is nothing we can mess this up. For us, it gives a variety of materials. The first one is steel, which is us. That's all we're using here is steel on these tests. It does also give mention to stainless steel, aluminum with an optional spool reel on it, and another aluminum option that's there as well. So none of these really matter to us. It's just steel right here. Here we go on to the suggested wire types. So we have solid wire ER70S-6, and then flux core down here below. So all three, so ER70S-6, ER70S-6 as well, and then flux core, which flux core has nothing to do with us here in auto collision or anything, period. Going on to the next one, it gives us our types of gas. We are always going to use a 75-25 mix. So it's 75% argon, 25% CO2. If you remember one back, ER70S sits right here. We have the option to run 100% CO2, which we talked about in the class. We will never actually run that here. So steel, ER70S-6, 75-25 mix. Now I need to determine my voltage that I'm running. Am I running 120 volts or 240 volt? Let me get my two different types right quick. Got them locked up. Okay, so coming back to it, our two different types of voltage we can run are 120 volt or 240 volt inside of here. This plug is going to be synonymous with the 240 volt. You may have also heard referred to it before as 220. They fall in the same category. This is what you guys may recognize as a traditional 110 outlet, or as they're calling it, a 120 volt outlet that's through there. We will see this be the only difference that's inside of any of these welders that are here. Some will be running 220, some will be running 120. For this particular welder, we are going to be running a 220 setup, which simply means that I need to find my wire diameter size and then take it over to this area. So it's very vaguely shown, but you see a light blue from here to here. That represents 120 settings. This medium blue from here to here, that represents the actual 240 volt settings that are through there. So back to it again. Material is steel. ER70S-6 is our wire type. 75-25 is our gas. Wire size is 0.024. Now don't be confused. I said 0.023 here, but 023 to 025 all fall in the same category for settings here. 024 is what we're going to, and now we're at this top line right over through here. So do I have 24 gauge, 18 gauge, 14 gauge, 3/16, 3/8? It all has settings that are calculated for that. I love to run my iCar settings for how I'm welding based on these settings alone. There's no point in fine-tuning gauges to what works with it whenever these gauges already have, this welder already has specific settings that are there. For instance, let's say that I'm welding a 2022 gauge and my recommended setting is 4.5 at 45. I'm just not having the same success with it that, that I want to with it. All I'll do is go down one setting to 5 at 50 and try that through there. I'm going to say 99.5% of the time, that simple step down is enough to be able to find those settings through there. What you guys are going to find is many of these settings on iCar are the same weld, just in different positions, and you'll basically have 1 to 3 different types of welding, like welder setups that are there. So any questions about this through here? Okay, so let's just call it, I'm going to set up at 5.5 at 60, which is recommended for 16 gauge. As I spin this guy around, we're going to see the front side that's through here. And we're going to see a series of gauges, 3 dials to be specific, not gauges, dials. 3 dials specifically. All of these welders should always be pushed up in the vertical position. That stands for mid steel C25. That's the only one that we're going to run. If we go one click to the side, that's running a pure CO2 MIDS, which we're not going to do. Aluminum further over, stainless steel or flux core. We are in just the vertical position, MIG steel C25. So 75-25 MIDS. Nets through here. I have a gauge set from 1 to 10 specifically here, and I have one on this side from 10 to 100. So 5.5 at 60 is where it is. So let's change it. Let's say maybe I need to go 6 at 70. That's all I have to do is just rotate that over. This does not continually go clockwise. It is left or right is all that it is. So don't try to jump from here all the way over to here. It's not going to happen. I have to take it backwards with that. Final few things to look at is going to be my grounding clamp. Notice how we keep them tidied up inside of it through there and hanging on this side. I also have my mid torch here, which we're going to try to keep just hung right through that. We want to try to avoid any types of tight kinks or bends inside of that, because we're feeling that may lead to early wearing out of the liners that are inside of there too. So we'll talk about the liners coming up. Here's our torch though. This is the most commonly serviced item that you guys will encounter with it. We're going to have the torch handle itself here. So torch being the MIG gun, you may have also heard it referred to as before, but the torch is how it's always been taught. Torch here, trigger here. This is going to be the gas flow nozzle. So this nozzle through here is what's going to direct the gas coming out of here and flow it right to our specific weld. We have the wires sticking through, which we see right now. The tip itself, which is right in through here, this will be fitted equivalently to the wire size that we have. So this is fitted to 023 specifically with that. Our nozzle dispenser through here. The reason why I say these are the most serviceable items, these tips can wear out just from continual welding with it. If we notice any issues that are there, more commonly if you guys make a mistake and get too close, you'll often put all of these three things in the puddle itself. So the wire feed that's going into it and the tip itself, and end up welding that shut, which can lead to further problems as well. The nozzle itself, this is something I clean out every single time I weld. So if you have the welding specific pliers, this is very easy to do, and I will get a set of those right quick. Last but not least, these will be our welding specific pliers that are through. This is a brand that Miller makes, but you can buy them at a lot of different outlets that are there. Honestly, the Harbor Freight one hasn't been too bad. We see through here, we have a pair of side cutters there that are there. I can easily trim that wire off and have it to where I need to be. Specifically, if you use this side that has this open indentation, that's actually supposed to be there as a pre-designed guide to make your wire the same size every time, like same length sticking out every time. I feel that to be a bit long. I like to have about 3/8 of an inch sticking out is all the more that I like with that. I can also use this serrated part through it here. If my torch gets stuck, I can twist that guy loose through there or just break him loose simply. I can do the same with the tip with that little serrated edge inside of there and be able to break him loose to twist him out or snug him up. Snug is as tight as any of these things need to be, no tighter than that. The final function these can have is if I get buildup and stuff inside of my nozzle, which is common, I can take that nozzle off, inserting that into it and twist around and knock anything loose. I do like to give some taps just to make sure everything's actually emptied out though. Are there any additional questions that we might have?